So we talked about dimensionality reduction, and now we want to cover the concept of numerosity reduction, which is basically reduce the data volume by choosing alternative, smaller form of data representation. One effective way is just to remove some of the observations. Um, um, so in numerosity reduction, we have two general strategies. One is parametric method, which basically means that if we can fit data into a model, then we just need to store this model, store the parameters and the outliers, and we don't need to actually store the data because all the data can be derived by using this model. So if we have a log linear model constructed or regression line function established, then we don't need to store all the data. We can generate the data whenever we need to. And sometimes those regression functions can be directly used in the mining task itself. Those are more advanced mining methods that we're not going to talk about in this class. The second more general approach is non-parametric methods. We don't assume a model. We just perform methods that actually can create a smaller form of data that is representative of the original data. So for example, we can use histogram and binning as one method. We can using clustering method. So for in clustering and histogram methods, the idea is to group things into a interval, into a bin, into a cluster, whatever it's called. But there is something that's representative of the specific data points. For example, in a cluster, we can compute the centroid. That's the mean of all the observations. Therefore, we can use that centroid to represent an entire cluster of observations. Histogram and binning is the same idea. Sampling is another idea. I think probably most of us knows what sampling is. It's just to obtain a small random sample that's representative of the original data set. And sampling is widely used in machine learning in the sense that we're going to sample to create training and test data sets to train a model and then evaluate the model on that data set. We can also, algorithm can sample observations, especially when you have cluster. For those clustering algorithms, the data set is so big that the data set cannot be loaded into the memory for the algorithm to compute the clusters. Therefore, the algorithm need to perform some sort of sampling to get a representative data set that can actually be processed within the memory. There are multiple sampling methods, and some basic and easy to use and widely used method are covered here. You can read the text, but I have pictures that will be easier to look at it. The simplest method is simple random sampling without replacement. So if this is the raw data, we randomly select, so the chance for us to pick any of the ball would be the same. We randomly pick one, and then pick the second one, and pick the third one. Without replacement, anything that's been sampled are in the sampled data set, we don't put them back. So this is simple random sampling without replacement. This method, here, this example shows simple random sampling with replacement, because you can see we have those blue balls occur twice. So first time we random pick out this and we put that back. We already recorded that we picked the blue and then we put the blue back, and then we draw again. Well, by chance we draw a blue again, and we record that we draw a blue and then we put blue back. And the third time we draw again, this time we draw pink. So this is simple random sampling without, this is with replacement. In most of the method, for us to actually do numerosity reduction, we will use this method way more often. I actually have not seen example of using with replacement. This kind of simple sampling has a problem because we cannot guarantee this output, this sample is representative of the regional, because if certain things occurs very rarely in the general population, then the chance for us to pick that into this sample going to be very small. We may never sample any of those. So for example, when we need to study school children's academic performance, if we put all the students into one pool, students with learning ability accounts for a very small percentage of the whole population. If we do a simple random sampling, our sample may not include any student with a learning disability. So that may not be a very good representative sample for certain mining tasks. So in those cases, when you know that your data already have certain grouping, certain characteristics, and you want your sample to have similar representation as the raw data, you want to use stratified sampling. So in this example, we know there may be students with different I don't know, a race, maybe that's the easiest example, that we want to make sure that our sample is representative in terms of race. So then we will group student of this green race and white race and blue race into groups, and we make sure we sample the same number of same percentage of each same percentage of the observations from each of the group. So this is stratified sampling. Clustered sample is it's very different. And in your assignment, there is a homework question asked about this. Every semester, we have student got it wrong. And so every semester, I emphasize this, and I hope this time we won't have any student get this wrong. So cluster sample, what does that mean? If our regional data has been performed a cluster analysis and we have identified clusters, and now cluster sampling basically going to pick from those 3 clusters, pick one sample cluster. So now we're treating every cluster as observation. We pick one cluster, so in this case we pick the blue cluster. As you can see, the result is very, very different. Here we only have one cluster. Out of multiple clusters that's been sampled. Right. Another strategy in numerosity reduction is the data cube aggregation technique. This is also related to our drill down and roll up example that we've seen before. The idea is data cube. The idea of data cube aggregation is we actually, from one large data set, multi-dimensional data set, we create many smaller representation of the original data set. Every small representation takes a certain combination of the dimensions, and then it creates multiple aggregation. At the lowest level, we have the base cuboid. So a data cube equals mini data cuboids. Okay, and then in a data cube, there is one cuboid called base cuboid. It holds everything. And then from this base cuboid, we can create multiple levels of different aggregation of the base data contained in the base cuboid and create different levels cuboids. One is more aggregated than the other. For example, at the beginning, we have sales per quarter, and then at a different level, we could have sales per year or sales per quarter per year or per 10 years. So you get the idea that we can aggregate the data. The higher level we go in this cuboid ladders. We're going to actually talk about this in more detail later. Because we have the data actually represented at different levels of aggregation, therefore, when we need to answer certain queries, we can pick the right level, aggregation level, and using that representation to answer questions or queries. The purpose of creating data cube is to answer complex queries for decision making. In this context, we are talking about create different aggregation levels of the same data set so that in order to answer certain queries, you will retrieve the data cuboid at that level and use the data at that level to answer the query. This concludes our discussion on numerosity reduction. Next, we're going to look at scale differences in data and how to normalize them.